Let's take a look at this problem. Okay, we got find an expression for f of x and state its domain. F is a function that takes a real number x, so this is where we're starting, and we're going to transform it. Perform the following three steps in the order given. 1, take the square root. So we're going to take the square root of whatever our previous transformation was, which is simply an x. Step 2, make the quantity the denominator of a fraction with numerator 4. So put 4 in our numerator, and we put the previous transformation in the denominator, and then subtract 13. So we'll take our previous transformation and we subtract 13. Now this would be our function. If by chance they were to rewrite this as a single fraction, they probably wouldn't, but if they were, then this would be negative 13 square root of x plus 4 all over square root of x. It's not bad to show this, because if you're going on to calculus, then it's useful to have single fractions sometimes in calculus. Now what I did is, this is the mixed number rule. Even though this may not look like a mixed number to you, we're taking the item to the side, which in this case is negative 13, we're multiplying it times our denominator. And then we're adding our numerator, and our denominator is remaining as is. And this is another way of writing your function, minus the d and d. Okay, our domain. We got two issues here. One of them is you got a fraction, and when you got a fraction, you got to worry about your denominator equaling 0. So to find out what value causes us problems, what you do is you set your denominator equal to 0. So we'll set the square root of x equal to 0. Now we want to solve this, and this is a radical equation. Our steps for solving a radical equation: first step was to get a radical by itself on one side, nothing in front of it, nothing after it. That's done. Second step is to raise both sides to a power equal to the index. Index is whatever number is in the slot, and if there's no number there, it's by default 2. So we're going to square both sides. Now the square root and the second power cancel each other away, and we get x is equal to 0 square root of 0. Now this is the value we cannot have. X cannot equal 0, because if I put 0 in here, I'm going to have square root of 0, which is 0, and I'll have division by 0. So we can't have that. Okay, now our second issue is we got a radical with an even index. And what you do there is you take what's underneath your radical, which in this case is just a single x, and you set it greater than or equal to 0. This is what makes sure that it's not negative. And then you solve this. Well, this is already solved. In interval notation, this would look like this. You put bracket on the 0 because there's a line underneath. And then it goes to positive infinity since we've got a greater than. But over here we just said that x cannot equal to 0. And a bracket means it includes 0. So we transform that. So we put a parentheses here, and by putting a parentheses here, this says it does not include 0. So this would be our domain.